Shubhodayam. Shubhodayam. Welcome all to this session of seventh batch of certificate course on Sanatana Dharma, organized by Veda Samskruti Samiti in association with Vishwa Yoga Vidyapit. Today we'll be starting a new class on subject, that is Vedic mathematics, by Dr. Goutham Mukherjee. It's a new branch or new subject which some of you must be already familiar, but it is important that we pay attention to the basics and fundamentals of Vedic mathematics and understand the simplicity and the varied application of Vedic mathematics. We'll start the day with Vande Mataram. Vasundhara garu, can you help me in Vande Mataram?
Namaskar. Shubhodaya. Vande Mataram. Vande Mataram. Sujalam Sufalam Malayaj Sitalam Sasya Syamalam Mataram Vande Mataram Suprajosna Pulakitayamini Ullakusumita Sumathura Shobhini Suhasini Sumathura Bhashini Sukhadam Varadam Mataram Vande Mataram Vande Mataram Vande Mataram.
Dhanyavadalu, Vasundhara garu. Thank you for the nice singing. Now I request Ram Sharma garu to do the pradhana, please.
1 minute meditation and 3 times Omkara. Om. 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 Om Ganana Tva Ganapatigum Havamahe Kavim Kavinam Jeshtarajam Brahmanam Brahmanaspata Anasrunvan Noti Bisida Sadanam Om Sri Mahaganadipataye Namaha Om Prano Devi Saraswati Vajebhirvajanivati Dhinamavitriyavatu Om Sri Mahasaraswatye Namaha Gurureva Gati Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave Naguro Paramam Sisurasmi Guro Matirasti Guro Mapahi Guro Jnananandamayam Devam Nirmalaspatika Krutim Adharam Sarva Vijnanam Hayagrivam Upasmahe श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतं गमय ॐ शान्ति शान्ति शान्तिः मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः श्रीगुरुभ्यो नमः हरिः ओम्
ధన్యవాదాలు రామ్ శర్మ గారు. థ్యాంక్ యూ వెరీ మచ్. Now I request Goutham. Acha, before I request Goutham Mukherjee, let me give you a very, very short, brief introduction about Goutham ji. Dr. Goutham Mukherjee, he has been associated with this certificate course on Sanatana Dharma since the beginning of the first batch. He is so involved and interested in teaching Vedic mathematics that he has been a student of all the batches. Though he is a faculty, he attends all the classes of the basic level as well as the advanced level. So he is a student as well as the faculty. Academically, he is a doctorate from Kanpur University, IIT Kanpur. Then he served in National Institute National Informatics Center, NIC, and retired at the very senior level. And then, since then, he has been pursuing his passion on Vedic mathematics, and he has done a lot of research in this field. And his proficiency in this subject is so high that at times, though very simple, it looks very simple for him to explain certain things. Even a very, very complicated issue, he teaches in a very, tries to make it very simple. So have patience and understanding Vedic mathematics, a very important subject which has been forgotten over the ages and again getting into prominence in the recent times. I request now Goutham ji to take over and continue with the class. Welcome, Goutham ji. Sorry for the very, very brief introduction about you.
Thank you, Babu Garu. Sarvebhyo Namo Namaha. I will start the presentation. First, some of you maybe may have gone through this thing. So, first few slides actually gives the very basics of the number counting and mathematics numbers and so on, how the numbers appeared and how the counting started. So very very initial kind of counting, as you know, we can count by drawing lines or in fingers and some the folds of the fingers and so on. So it is like this, that there is to be groups of 5, that is, it gives some easier way of counting. That is when the no kind of sort of number system came up. Then after that, Babylonians used the various symbols, this for 10, 100, etc. And Roman number system, as some of all of us know, that this I, V, X, etc. These are used for various kinds of numbers, and these are additive. They actually just add here like this, add or subtract, depending upon the position of the numbers. So these are called ordinal numbers. They are used for, ordinal numbers are used for labeling something, not calculation. However, cardinal numbers are used for calculations. So this you can go through initial these things, and the first serious the number system came with the positional number system of India. And that is this Aryabhatta and so on. In 7th century, it spread to the whole world. And and where this positional number systems are basically, we know that it is 1 to 9, these are numbers are there, and then there is absence of that numbers, or that was the, how 0 was discovered. And so actually the basic thing is that number of symbols 0 to 9 is equal to the base 10, in this case 10. Now after that, after the invention of 0 in the as a corollary of the positional number systems, various properties of the that 0 was found. These calculations all of us know, and that those are the various calculations with 0 came, and these are the 830 AD, this Mahavira, the Gonita, Sarasamhita, and so on. So there are a lot of, I'm not going through very these things very deeply, but we'll go to the main topic. So the concept of base is there. We know that our natural base is 10. It started with 10, and then so therefore it's called decimal system. And so the symbols were 0, 1, 2, 3 to up to 9. And then this number system, decimal number system, actually has gone from India. It went to the whole world, and still it is the dominating number system. However, when computers came, it was found that computers have only 2 states, namely that whether current or voltage is flowing or not flowing. So there are 2 states. So those are denoted as 0 and off, 1, like on and off. So that gave rise to binary number system. And not exactly binary, but when they are grouped into 3, it gave the octal number system. Some computer used octal numbers. And dominantly in present day computers, they are grouped in 4, and this is called hexadecimal numbers with base 16. Octal was base 8 and it is base 16. 2 to the power 3 and 2 to the power 4 here. Hexadecimal means 2 to the power 4, 16 base. And digits were 0 to 9, the same digits as decimal digits were used. And then A, B, C, D, E, F. These were used as digits. And they denote the numbers 10 to 15. So, but otherwise, in common use, always the decimal number system is used. So, are we discussing here? Now, there is a concept called place value and the face value. Place value and face value. So, this is this unit 10, 100. These things actually are called the place value. Whenever some digit comes there, so it gives a proper, according to the place value of the system, this gives a, it gives a into 10 to the power some power. And the face value comes, the numbers which are there are called face values. So, for example, here in 756, it is 7 into 10 to the power 2 plus 5 into 10 to the power 1 plus 6 into 10 to the power 0. Or 7 into 100 plus 5 into 10 plus 6. So 7, 5 and 6 are the face values. And 100, 10, 1 means 10 to the power 2, 10 to the power 1 and 10 to the power 0, which is 1, are the place values. So 10's power, these are the positional, the place value, positional value, you can say also. And then the numbers which get occupied there are called the face values. Now, negative 10 power, place values, they are actually, they denote fractions. Like in the decimal notation, say for example, 0.34 will denote 3 into 10 to the power minus 1 plus 4 into 10 to the power minus 2 and so on. So if you have some number called, say, 123.456. So 1 into 10 to the power 2, 2 into 10 to the power 1, 3 into 10 to the power 0, and then plus 4 into 10 to the power minus 1, 5 into 10 to the power minus 2, and 6 into 10 to the power minus 3. That way it will go. Now, however, in mathematics, or our conventional or modern mathematics, negative face values were never used. These are called vinculums. Actually, these are the some things are there. Some calculational issues are there with vinculum. They can be solved. So these are using basic mathematics only. Now, so how the numbers are, these are the English numbers 1, 2, 3, 4, as so far we have seen. However, throughout the world, there are various cultures, various languages use their own mathematical symbols. So I've shown here that how those numbers all can be handled now, and they have a particular Unicode values are there. And how to use this, how to type that Unicode value? You type that code and then place on the, say, MS Word, you then do the Alt X onto that. And you can do that. Actually, by setting also, by certain settings, when you do the Unicode setting in the your laptop or computer, and there you use the numbers, you can directly type those on the on your on your laptop or desktop. In obviously you use also in mobiles. So those are actually coming from your language setting. Directly you can type that, and interestingly, they can be directly used in MS Excel kind of calculation. Any calculation using MS Excel, for example, they use those. They accept those numbers as numbers, not as characters, not as text. So these are given here. Say, for example, if you want Hindi, for example, say, for example, Hindi 5, what will be the code? 096 and B. That will be 5 of Hindi. And Tamil, for example, say Telugu, say 4, this 4. How it will come? 0C6 and this A. As I told that A is actually 10. So this is the A. C is also 11, 12. So these 0, 6, A, these are used, A, B, C, D, E, F are used as numbers. So these are these symbols, you can say. This will give this particular code will give these numbers. Similarly, outside India also, there are so many others, Arabic, Thai, Lao, and so on. However, as I give here, in Chinese languages, I have seen that the character set, these are the some numbers are there, but they are only text format. I tried them with MS Excel, but they didn't produce any calculation. They used as a text. They accepted those MS Excel accepted those symbols as texts. Now we come to basic mathematics. Now basic mathematics is actually it's an intuitional use of 16 basic sutras, or called formula, or 32 sub-sutras. Now, presently, actually there were more, but presently it came to like this. And Jagadguru Swami Bharat Krishna Tirthaji Maharaj, he very deeply he studied all these things, sort of meditation, and he formulated all these different Vedic sutras and so on. And however, he got the clue from Atharva Veda Kalpa. Actually, he expanded, you can say, expanded from that. Very subtle kind of those sutras are there, but he deciphered them and expanded it and gave to all these. Plus, his own intuition, own meditational knowledge, he formulated so many sutras. And Vedic mathematics is a collection of various alternative methods in solving mathematical problems. If practiced, it is a potential to develop better control on number system starting from school level. So you can say that these are the alternative methods. We normally learn each of one this subtraction, addition, subtraction, multiplication, and division. We learn very few of the methods in school. However, with this learning basic mathematics, you see that there are alternative methods also, and you can always choose the best method. That is the main idea of the learning basic mathematics here down. So this is the book. I will give the link also. You can search in Amazon or Flipkart Vedic mathematics by Bharat Krishna Tirthaji, and you can order them. It is 220 or something like that. Now, what are the main formulas? 16 sutras. They are ekadikano purveno, one more than the previous. Nikhilam navatas charmam dasata. It means that all subtracted from 9, but one last one subtracted from 10. So not subtracted always, but Nikhilam, this symbol that from all from 9 and the last from 10. Urdhva Tijagabhyam, upward and slant. So there I will explain those things later. Paravarta Jojayat, and so these are all these are just photocopies from that book. There are 13 sub-sutras also. And these are the some meanings are given here. Means one more than the previous. Nikhilam Navatra Saramatra means all from 9 and the ultimate from 10. Urdhva Trijaga Bhavin with upper and slant. Paravarta Joyat is transpose and apply. Shunnam Samba Samuchate. A common factor is the same with 0. This will actually gradually some of them will use, and throughout our course, we will use some of them. Charana Karanabharam. These are actually this called actually differentiation. So these are all these are given in this one. Some of the meanings are given. Now, what are the scopes of Vedic mathematics? They give arithmetic computation, multiplication, division, recurring decimals, divisibility, highest common factors, square root, cube roots, etc. Then equations, factorization and differentiation, and integration. These are some of the examples. Now, this we never actually concentrated on the background algebra. We just learned the procedures in schools: addition, subtraction, multiplication, division. We just learned the procedures. However, all of them have some or other algebraic background. Now, that inherent algebra I have written here? Inherent algebra is changed. The procedure can be changed. But however, for an alternate procedure, you need a practice. You may know that the background algebra is there, but you always may not, unless you practice it, it will not be expert. It will not be expert on that. Now, in this session, we will learn some of these alternative procedures. In mathematics, both positive and negative phase values. I already mentioned that once. Negative phase values are used, and these are called vinculums. And if the digit is more than 5, it is better to use the negative phase value rather than the positive one. For example, 48 can be expressed as 5 and vinculum 2. Basically, it is negative 2. So here it is 40 plus 8, and here it becomes 50 minus 2. It is the same thing. So when some calculations are there are places where we'll find that we do not use 8, but rather using 2 will be easier. The concept of vinculum is explained here. Actually, this everything are on the computer, so we have to use computers to give this, transmit this, and there should be some way of writing all these things, whatever you use. So I found that there is no nowadays actually every character is used as Unicode. So we found that there is no single symbol for this vinculum, number with bar above. There is no symbol for that. There are other, say, dot is there, sometimes some, say, with a something, some tilde is there, and so on. But this bar I could not find with this thing. So there are, I found some ways, like here is a picture. It is actually a picture is drawn here. So that way, that is the writing way. So that is the one thing. This one gives this 305 gives this one. So whatever it is, forget it. Now the concept of vinculum comes like this. See, 37. Actually can be expressed as 40 minus 3. So instead of the 37 can be written as 4 and 3 vinculum. Like it is, this negative symbol comes above, you can say. And obviously 4 in the tens place gives 40. So similarly, 97, is 100 minus 3. So there will be 1, 0, and then 3 bar above. Now here 143, vinculum 143 to write. So it will be 143000 minus 143 is 142857. Now how easily you can do this subtraction basically, but we can also use the formula called Nikilam Navatas Charvang Dasato, all from 9 and last from 10. And Ekonunano Purveno or Ekajikano Purveno also, depending upon how you are convert. How you convert from whether from vinculum to normal number or normal number to vinculum. For example, I give you an example here. Say, for example, 3 and 1, 3, 2, 4, 4 on vinculum. Nikilam Navatas Charvang Dasato. You first you do, whenever you do from vinculum number to normal number, you do Ekanunana Purvena, means that 3 becomes 2. And all from 9 except last from 10. So 9 minus 1 is 8. 9 minus 3 is 6. 9 minus 2 is 7. 9 minus 4 is 5. And 10 minus 4 is 6. Is it clear?
Gautamji, I think your screen is not changing. The slides are only on the 16 sutras. Yeah, are you still on the same slide?
No, I am changing here.
But it is not changing. So I think you have to redo something. The slide is not changing. It's got stuck at 16 sutras.
Is it?
Yeah, yeah. Is it true only for me or others are also seeing only 16 sutras?
No,
Can
only
anybody
sixteen-
say?
only 16 sutras.
Yes, sir,
I
that
me-
is only.
I messaged also.
Right, right. I've seen that. Yeah.
So is it stuck?
It is stuck. This
Yes,
slide
sir.
is stuck.
16 sutras and I sent message.
Right,
So
right,
So
right.
I
I've
think
seen
you
that.
have
you can stop sharing and then
pointed
reshare
out.
again.
I can stop sharing.
And then reshare.
So should I discuss again all those things?
Maybe you can glance through because whatever you said is coming, but the slide was not
Obviously.
moving.
Now I will also monitor with the other one my
Yeah,
my mobile.
right, right, right.
That will be good. Okay. There are some hazards.
Yeah, yeah, yeah.
And here
Now, which slide you are trying to teach? Arithmetical computation is on the screen.
arithmetic, yes. Now arithmetic competition is there.
Right.
Oh, so now I'll mute this.
Yeah, you mute the mobile.
This is just for monitoring. I am keeping one.
Yeah, yeah, take. Got it.
Okay, sorry for all the interruption. Now, arithmetical computation, I discussed, now, these 16 sutras were there.
There's a question, how these hex codes are decided?
Huh?
How these hex codes are decided?
Acha, okay. Hex codes are decided. Oh, acha, these hex code of these numbers.
Yeah.
Actually, hex codes are given to everything, then I have to first discuss slightly more. There is a ASCII code for all the, say, before inclusion of all various languages of the world, only English was there, and each English alphabet, their symbols, comma, full stop, bracket, and so on, they gave on the ASCII code, you can say. They are called ASCII codes, American Standard Code for Information Interchange. Then there are some additional symbols also, they were given. However, these are actually called in the 256 range, 2 to the power 8. Now, when the need of inclusion of all these symbols of the world, all the different languages, all the when they wanted to include that, so that 256 number was very small. So they used 16 bit, 2 to the power 16, 65536. So those are extra, those part is called double bit, double byte, 16 bit. So that is called Unicode. And those codes are assigned. For example, Hindi is assigned 09002 09 FF, something like that in Unicode term. So within that, 0966 to 096F came as these symbols. So 16 bit, 16 bit or this 4, these are actually 4 groups in 4. So 0 means 0000, 9 means 1001, 6 means 0110. These kind of things is there. So if you can expand in 16 bit total, this is just 4 into 4, there are 4 hexadecimal digits. So, and the computer will recognize with this 0 and 1 pattern. And they are assigned. So there is international assignment for all these things, symbols. So that way. I hope I'm clear.
Yeah, go ahead. Yeah.
Okay, please. Acha. Now I was here and 16 sutras, then 13 subsutras. These are, and here I gave, actually you can see your letter, you can see your presentation is already shared. So you can see all these things, meaning of these things, and the scope of I read them out: arithmetic, computation, multiplication, division, and so on. Now here now they come to concept of this vinculum. Here one discussion was there. The background algebra is changed. The procedure gets changed. We learned procedures in schools, but we never used other algebra. Only one kind of algebra is there in background algebra is there, and later we learn algebra, but we only practice the arithmetic part of it. That arithmetic actually we practice. So it needs some practice. A child needs quite some time to practice all these things in the even addition, subtraction, multiplication, division. So Vedic mathematics are the alternative procedures. Alternative algebra, they give alternative procedures. So here one concept called vinculum is learned here, that the like 48 is, we know this positional number system. 4 is the place value. 4 and 8 are place values, and the 10 and 1 are the positional. I mean, 4 and 8 are the face values, and 10 and 100 are the place values. So whereas, so it is 40 plus 8. So similarly, it will be negative. It is negative face value. -2 is the face value here, and 5 is the face value for this one, 10th position. So 5 into 10 minus 2 it becomes. So it becomes, therefore it is like this, 48 it comes to. So that is the a way of calculation. using vinculums. So here some vinculums are how they can be used is given here. So for example, here I have given one thing. I write them in a different format. So for example, the problem was 3 and 1, 3. You can see these things. 2, 4, 4. This is on vincula. How to convert it into the normal number? Now here you have to do eka nunnenna purvena. So I put it 2 instead of 3. And then or subtract from 9 except last from 10. Subtract from 9 is, here it is 8. Here it is 6. Here it is 7. Here is 5. So basically 9 minus 1 is 8, 9 minus 3 is 6, 9 minus 2 is 7, 9 minus 4 is 5, and 10 minus 4 is 6. So since all are above 5, we prefer to use vinculum. So this is vinculum notation. So the next example will come. Vinculum application of this application of the purpose. The negative phase value, vinculum means it will reduce effort of calculation. Means that sometimes you have to use 9, 8 and so on. Reduce the effort of the calculation. So by using vinculum, an expert can use only 5 by up to 5 into 5 table, not 8 into 8 and something 8 into 5 and so on. So vinculum, there are, as I told, I had some problems in writing in Unicode. These are extra symbols. After one, we write the bar, or I do use pictures, bar as pictures, or I found actually this negative, you can say the photo negative. Negative of the photo you have seen, that your white will be black and black will be white, something like that. So here actually this kind of symbols are used as vinculums somewhere. Now this is the calculation, example of the calculation is given here, how vinculum can facilitate us in reducing the effort of calculation. One example is given here. So here purposefully I have chosen numbers where excepting the first one, all are above, all digits are above 5. So how it facilitates, I will see. How? Now, this whenever I want to convert a normal number to vinculum number, what I do? Now I do ekadhikano purveno. 3 is converted to 4. And then 9 minus, you just consider it 3, 9, 6, 7, 8. So ekadhikano purveno, this becomes 4. 9 minus 9 is 0. 9 minus 6 is 3. 9 minus 7 is 2. And 10 minus 8 is 2. And put a above. So this is that is how it is done. Actually, basically, explanation is this: 40,000 minus 322. So this becomes that. So similarly, all these things are done like same way. Ekadhikano purveno, this 9 minus 7, 9 minus 6, 9 minus 8, and 10 minus 9. Here also, ekadhikano purveno, 1 is converted to 1 plus 1 is 2. And then 9 minus 8, 9 minus 5, 9 minus 6, and 10 minus 7. That way all are done. Then you find that calculation is easy. Instead of calculating 8 plus 9 plus 7 plus 8, I do 2 plus 1 plus 3 plus 2, which is 8. That way directly straight away I can do. There is no carry involved here. In this specific example, of course, the carry is involved. 3 plus 3 plus 4 plus 4. And 2 plus 1 plus, that carry 1. Carry can be there, yes. So finally it came to and this becomes this 4 plus 3 and this becomes 14. 14 and 6, 4, 6, 8 vincula. Again, we do this 1 came to 1, and here converting from this one to vinculum to non-vinculum, the ekadikano purveno. Sorry, ekonunneno purveno here. So 4 becomes 3, ekonunneno minor. So last of just before vinculum, whatever number is there before vinculum, that has to be ekonunneno. Here also, wherever I propose to put vinculum symbol, ekadikano just before that, not others. 1 is not touched. Only 4 is touched here. And here also 3, because there is no other one, only this one is touched. Ekadikano. This way it will be this way it will be plus 1. Normal number to vincular number, and from vincular number to normal number, it will be minus 1. The Purveno one. Other swar will be Nikhilam Navatas Charamakasata. It is the same for both the cases. Both the cases it will be sin 9 minus 3, 9 minus 5, 9 minus 3, and 10 minus 8. So this becomes the result. And in the explanation, it comes like this. What I did, basically by this procedure, by this algebra, background algebra is like this explanation, that you first one, the positive ones you added, and these negative things, higher numbers, more than 5 numbers are these negative numbers in the negative symbol, and all this you added, and then you finally subtracted. Basically, by learning an alternative procedure, we don't have to bother about the explanation. Always we don't have to consider what is the coming in background, but it becomes a procedure. By following the Ekanono or Ekadikono and then Nikhilam Lavata Sarmakasa. Is it clear why I wanted to do this? I gave another example. Here I give an example where it is alternative higher than 5 and lower than 5. 3, 9, 2, 7, 4. 3, 9 becomes 4, 1. See, this becomes Ekadikano here. I want to convert it vinculum. So Ekadikano, and then 9 minus sorry, it is only one symbol. 10 minus 1. 10 minus 9 is 1. So similarly, 2, 7. So it becomes 3 and vinculum 3. Basically, 27 is same as 30 minus 3, you can say this way. So that way 4 come untouched. So 5, and then it becomes this way. You can convert into alternative vinculum and non-vinculum. I'm using that formula. It is actually the single number is there. It is always from 10. If more than one vinculum in the block will be there, so there'll be a need of this all from 9 and last for 10. Only one symbol is there, so there'll be always, it will be subtracted from 10 only. It is that thing. Now you see that this way it is done. So it will be some now 4 minus 1 plus 2 minus 4 becomes 1. Okay. Minus 3 plus 5 minus 4 plus 1 plus 3 becomes 1. There is no carry was involved. See, here there are carry will be there, but here there is no carry will be required in this case, because it is negative also there. 3 minus 3 becomes 0. 4 minus 2, 2. Result. So minus 1 plus 4 minus 2 plus 4, 5. And these also 4 plus 5 plus 3 plus 4 is 16. The explanation actually is slightly complicated. I just gave that in a way cross kind of things. So explanation is not very clear, but actually you can just still infer that how it came actually. Here actually the alternative were there. So finally it came to 16 to that way.
If anyone has a doubt, please raise your hand and you can unmute and ask.
Yeah.
Seshagiri Garu, you can ask a question.
Sir, I couldn't get to what you were saying, sir. First, that can you again, please again explain it? Because the first minus and the one up, one down, that I couldn't get it. Please explain
This slide or the previous
slowly.
previous slide or this slide?
This slide, sir. Numerical vacuum.
Or the explanation part. Explanation part.
Yes, sir. Yes, sir. Yes.
Oh.
I couldn't. I like a 3, 9, 6, 7, 8. You said that, sir. In that you said the 4, 0, and how it comes that I couldn't got it.
How it came, no? Thus, I wanted to explain it. However, it will not be very proper actually, because see, basically this means actually, see, these are the positive one. So if you replace these negative ones, vinculums as 0, so it becomes 40304. This is 40304. And this part is negative. 1030. Sorry, it's actually 103, basically 1030. Here, I wrote these things here actually. 10 minus 1030. If I subtract this 403, 1030, it becomes again negative numbers and so on. So I wanted to avoid this. This just a sort of to be subtract, because I am see positive, negative. So how in this case it is subtracting, from whom it is subtracting? Because if I subtract this 1030 from this one, it will be subtracting from 0 actually. But here it will be made clear if these numbers this in proper place, the same place is there. So therefore I crossed it like this. Actually,
Gautam ji, I think
Yeah.
his doubt is how did 397 what are 774
3274.
has converted into 41 etc. Is this the point, Seshagiri Garu?
Yes, sir. Yes, sir. That is only, sir. The 39274. Then we said
Ah.
vinculum, that is a 41334.
So
This
No,
is
here
not
you
where
have to
413.
understand. Yeah.
No, don't call it 41334. 39.
Sir.
As I told
Yes,
that
sir.
if
39.
it is if the addends are more than 5, you convert it into vinculum. For making the calculation easy, for facilitating the calculation. So 39, we have to convert it into 4 and vinculum 1. How? Now 30 plus 9 is same as 40 minus 1, isn't it? This
Right,
vinculum 1 means actually negative 1. This is negative phase value.
Okay.
Here, normal
That-
numbers are all positive phase value always, but here negative phase value is also used in Vedic mathematics. That is the additional things that Vedic mathematics uses, which modern mathematics even do not use it normally. So therefore,
Sir,
even
what I
there is no symbol for vinculum. So it is very with great difficulty I have to use this.
Sir, that means what I understood is first we have to take the two number 39. 39 is a 40 minus 1 is equal to 39. Am I right,
Yeah.
sir?
Yeah.
And thereafter, then again I have to touch the two numbers 27. That is a 30. Is a
No,
30
no.
minus
So see,
20.
2 is below 5, so don't have to touch 2.
Okay.
7 is above 5. So therefore,
Okay, sir.
you have to get blocked, you have to also include the previous one. And with the help of the previous one, with increasing the previous one by 1, okay, you and convert it into vinculam accordingly. Ekadhikan, charamang dasato. In this case, only one, so charamang dasato means subtract from 10. So
The 2 is subtracted 10 is then come the 8, sir. Then it is 3 here. 27 is there.
27.
Sir.
So
Ah,
do
sir.
ekadhikana purveno. So you make it 3, and 10 minus
Okay.
7. 10 minus 7 is 3.
10 minus 7 is 3. Right, sir.
Okay.
Okay, but then the 2, then we are not touching 2, sir. Then 7 is there. Then are we taking 2 together, 27?
27. Always you see, wherever there is a more than 5 is there, you make them block like this. This is one block here. This is one block, and 4 is not touched. So sorry.
Okay.
This is
30, I could understand,
this
sir. 39 is one block and
this is
27 is
one,
another block.
This is 37 is there. This 49 is one. 83. Sorry, here 28 is one block. 36 is one. Here 38 is one. 26 is one block, because the second one is more than 5. More than 5. So with more than 5, you convert it into vinculam, and this previous one you do ekadhikana. Add one to that. You just
That
practice,
means,
you go through this again. You'll find that these
no, so I understood, sir. Reduce
the
effort of calculation.
Okay, I think you can go move forward.
Yes, sir. Yes, sir.
Later on you
Right.
can
One
you
small
can
Understood.
practice yourself
Ah.
sometimes, and then again you if difficulty comes, confusion comes, you
Right,
just
sir.
Yeah,
Right,
Gautamji,
sir.
if
Right.
you could just go back one slide, please.
Okay.
Go back one slide, please. Yeah, in the second column is understood. In the third column, how do you get this 0301 to minus 40304?
No, actually it came from with arrows I have indicated. No.
So 40304 is fine. That is, you've taken the vinculums into zeros, and then you've done minus 0301.
This minus actually it came like this. Oh, where is my minus actually came like this. This actually becomes minus 1030. See, again I'm considering only negative ones. So it is 1030. 0, in fact, 01030. So we have written below.
Yeah.
But purposefully I did that. Actually, it should have been coming the same line. Now, similarly, 54050. 54050. And this one actually in the proper, see this in the place this positive, also, these are the positive ones. So to subtract this positive from positive, I brought it down, and this I brought up, because this is positive ones are there, because this positive will, just to make an example, this these are the 301. 301 came here. Okay. So this 301, this to subtract these things from here, is to visualize. To this one, I brought it like this. Similarly, when you subtract this, but actually this is, I I consider that there is a cross subtraction is there, just to make it facilitate. That way, it is nothing actually. Corresponding to my example, this becomes like that. Nothing important actually. Just to visualize that. This is not very important. This is important. You understand this thing and do this calculation, it will be understood. Okay.
Yeah, no, got it, sir. Got it. Nice.
Now, there is a very popular kind of thing is there. Actually, some people, these are the, most of you probably maybe know this already, that whenever there is a this number ending in 5, squaring that, it becomes very easy. For example, First I gave the algebra, but actually it actually depends upon the practice, your practice, how it is. So 15 square, how you do it? Now 15, you do the always since 5 square is there, always make it 25 would be always there. 25 would be common thing for any number, squaring of any number ending in 5, it will be ending in with 25 only. But what will be the previous numbers? Now, in case of 15, the 1 into 2 you do. So it is 2. 25 square, how do? 2 into next, ekadikana purvena. This becomes 2, and that purvena, ekadikana of that, it will be 2 into 3. So it will be 6 and then 25. That will. 35 square, 3 into 4 is 12, and then that's right, 25, 5 square. So 45 square, 4 into 5, and then 25. Yeah, yeah. So 3025 square, 3022 into 303, and then 25. So it becomes 91506, and then 25. Is it clear? So the same kind of thing can be there. Sorry. You can do similar thing also. Say, for example, instead of ending in 25, you can multiplication also you can do. Say, I have to, say, for example, instead of 25, I do, say, 24 into 26, where the n numbers, in 24, 26, n numbers add up to 10. The same kind of facility will be there. Here we have to multiply this one by this one into 24. But here it will be 2 into 3 is 6. Isn't it? So say I do 21 into 29. Here we introduce 1 0, of course, 09 becomes. And then 2 into 3, 6. You can also see this. Huh? You understood what I told? If the, like, here actually 5, ending in 5 becomes 5 plus 5, 10. And here, it is, if anything other than 5 is there, but the two such numbers, the last unit digits add up to 10, then also you can apply this for Ekajikano or this kind of formula with this kind of things. Anyway, that is not very. So there is a these are some shortcuts are given, but actually there are always some rigorous mathematical background. There is no depth of rigidity in this. Now I come to the first very important ones. It's the multiplication near a base. So near a base. What is base? Any 10 to the 10 power, 10's power is base, 10 to the power something. So here this kind of pattern, you know that in conventional mathematics, this should be very cumbersome. Always use 9 into 9 into 8 into 9 into 9, this kind of things. Always use 9, 9, 9. People get very puzzled, and the child also becomes very, finds it very difficult. But however, since these are close to a base, alternative methods, namely this Nikilam Navata Sarmata Sutra formula, can be used here. So 97, I do, so it is below 10, below a powers of 10, power of 10. I put a minus symbol. And then Nikhilam Navatas Charamagdasata. 9 minus 9 is 0. And 9 minus 7 is 8. So 10 minus 7 is 3. Nikhilam Navatas Charamagdasata. 93. Put a minus symbol and then 9 minus 9 is 0 and 10 minus 3 is 7. So I write like this. So this kind of places are reserved for me. So that same kind of place will be there. Now what we do? Simply this 03 into 07. Minus 03 into minus 07 becomes 21. We do 3 into 7. 3 7 is 21. And here you do cross subtraction because subtract is there. Algebraic addition in this case is subtraction. So 97 minus 7 is 90, or you can say 93 minus 3, both are same. 9021 becomes my answer. As easy as that. I come with higher basis. 997 is minus 003. We get how 003 came? Because 9 minus 9 is 0, 9 minus 9 is 0, and 10 minus 7 is 3. Here also, Nikhilam Navatas Sarvangas. 9 minus 9 is 0, 9 minus 9 is 0, and 9 minus 3 is 7. So again, 3 into 7, 997 minus 007 is 990. So you have seen that, if we compare with these examples, earlier example also, earlier we had like this, 9021 was my answer. We find that introducing more 9s result in addition of more 9s in the first part and addition of more zeros in the second part. You can do any numbers of 9s given. Any student without knowing these things will be very puzzled with so many 9s. But it actually is very, if you visualize this correctly. So not only you do this calculation mechanically, you visualize what is happening. Visualize what is happening. Now it is very near to a base. Obviously, it will procedural with this. Don't always relate to the conventional mathematics. You use it as a procedure. So this is a procedure, it becomes a procedure. 997 and 007 became 990. Write in one first part. And the second part, you multiply with that whatever you got that from Ekadikano, Nikhilam Navatas Charamagdasata, Nikhilam formula. Basically, it is called multiplication using Nikhilam. So Nikhilam formula, what you get, you just multiply that. It becomes like that. So here I gave a different example. 9874. 9874. 9876. It becomes Nikhilam Navatas Charamagdasata. So 9 minus 9 is 0. 9 minus 8 is 1. 9 minus 7 is 2. And 10 minus 6 is 4. 9987. 9 minus 9 is 0. 9 minus 9. And 9 minus 8 and 10 minus 7. So here also I multiply these things. Here you can do by any method, you can multiply. Either you can use conventional mathematics or even that sometimes it will be needed to put a sub of this one. And you can do this, but here it will be cross subtraction. 9876 minus 13 is 0013 is 9860, or 9987 minus 0124 is the same result. Now, what is the background algebra in this? Here you use it as a procedure. Don't consider it always as a background algebra, but in the background there is algebra. What is that? Now, n is the base. Here in this case, n is, for example, 1000. And this part is this number I consider as n minus a, where a is this one. This is a. This is my a, and this is my b. And this is already n minus a and n minus b. I am evaluating basically n minus a, and I want this n minus a into n minus b. For that, what I am doing, Now I am doing n minus a minus b. It is already n minus a. I am subtracting b from that. Means that n minus a minus b becomes my this one. And while this what is this n doing in the back outer the bracket? It is multiplying this by so many digits, and n was 1000 in this case. So I have shifted that. My multiplication is inherent. It is automatic by shifting it so many digits, because I have already reserved those digits by my way of Nikilam Navatas Charamudasata. Same numbers of with the base, if base is 1000, I have already reserved 3 places for that. You don't have to bother by writing this way. This multiplication by n is automatic. And then I do plus what? Plus this AB. This multiply A into B, I multiply, and it becomes. Is my expression correct? You understood?
Yes, sir. All this is understood. Only the last one I know is the multiplication of minus 0, 1, 2, 4, and 13 to get 1, 6, 1, 2. But what is the shortcut? Unless you know the table of 13 to do 3, 4, 2 balance 1, and then you do that, it comes. But what is the shortcut to do 124 into 13?
124 into 13. You will basically, these are small numbers. So it is not, it will not come under this formula called Nicolam formula. There is a thing is there. You do, here you do 4 into 3 is 12. So 2 and carry you right below. Okay. Here it is called the Urdhati Jagabham.
There is a
3,
traditional
2
multiplication.
into 3
like
plus 4. So it becomes 0. 2 into 3 plus 4 into 1 becomes 10. 0, and you write 1 here. Okay. And here you write 1 into 3 plus 1 into 3 plus 4 into 1 is 7.
7.
No, I made a mistake. 1 into 3 plus 0 is 0, 1. 1 into 3 plus 1 into 3 plus 0 is 3. Okay. Yeah. 1 into 3 plus 4 into 0 plus 2 is 5. 1 into 3 plus 2 into 1. 1 into 3 plus 2 into 1. And then 1 into 1 plus 2 into 0 is 1.
So 16, 1, 2.
Okay, and 1 into 0 is 0. So this is the procedure of the Urdu Tityagabhag. And carry you are there only this one, and then finally it come to 1, 6, 1.
Yeah, thank you, sir. Thank you.
That way it can be done. Here actually, as I was telling, this is A and this is B. So it becomes 1, 6, 1, 2. Here and then how it comes? Now this is already this is A and B. This is already n minus A. This is already n minus A, because n is my, this is n, 10,000. This is already n minus A. Further, I subtract B from there. I give rise to this one, which is 9863. And multiply by 10 means this shifting to 4 digits left. That means it is multiplying by 10,000. And then AB, this plus this AB. So this is very, sometimes people may tell that this is not rigorous, but it is very rigorous. I'm only using a different procedure. Like my division, for example, a child learns division. Lot of algebra is there, but mechanically they learn how to place the digits where, and then works out that division process. Similarly here, if a child starts learning this thing from childhood and learns this procedure, it will be automatic. It will not be any unrigorous anything. It will be very rigorous mathematics, because background is different. Here I do multiplication, similar kind of multiplication, but above base. What is that? Now here is 103. Here you do plus how much it is above. Similarly, preserving the number of digits plus 03, 100 plus 03, 100 plus 07. Similarly, 3 into 7 is 27. 103 plus 7 is 110, or 107 plus 3 is 110. Similarly, you do 110 and 21 is the answer. Similarly, increasing zeros, both multiplicants result in addition of same number of zeros in the first part and the same number of zeros in the second part. So it will be 1007 plus 003 is 1010, and 1003 plus 007 10, same thing, and say 7 into 3. Similarly, I purposefully gave the same example. Here you do here also 1 2 3 into 6 1 5, and 1 0 1 2 3 plus this 5 1 0 1 2 8. Similarly, it is n plus a, but this is a and this is b. These are a and this is b, and in this case this is n 10,000. If you have seen that, this is already, and further I add again b, or this is already n plus b, I further add a, same thing, n plus a plus b, and then shift it, multiplication by this particular n means shifting it towards right, left, and then plus into ab. So this way you can practice it. It is a matter of practicing the this one will be, with practice it will be perfect. Now, if it is mixed, what to do if it is mixed? So in this case, here it will be Nikilam formula minus 0.7, and 107 is plus 7. But here it will produce, upon multiplication, it will produce, the AB part will be negative, 49 will be vinculum. And then 93 plus 7 or 107 plus minus 7 becomes 100. So it becomes 93, it becomes 100 and 49 vinculum. What will be that? It will be Ekanunna Purvana. So 100 becomes 99 and 49 becomes Nikilam Navdastar 10 minus 4, and or this way you can say 9951. Okay. More example. 1013 into 993. So similarly it will be this one 091 and 1006, 9996 here also, and 0021. So becomes, this will be upon converting the vinculum into normal number, it will be that formula Ekanunno and then Ekanunno and then Nikilam of the Saramadash, it will be founded. Here also it is mixed expression is there. N plus 1, here it is A, and here it is B. B is negative here in this case. So it is N plus 1, this is N plus A, and then do minus B. Or it was N minus B, and then do plus A. So whatever it is, it becomes like this. And then multiplied with, multiplying with N means it is shifting. And then now it is minus AB, minus AB. So you to put the vinculum symbol, the AB we calculate and then do minus on that. So minus means you put a vinculum there, and then finally you calculate. Or you do the same thing, 99960000 minus 21, same thing. By Nikilam Navadas you are doing, but actually background it is the same algebra is, this algebra is acting. Now with a, what to do if carry is involved. So far I didn't consider that one, but if carry, what to do if carry is involved. For example, 86 into 84. So 86 minus 16 the same way, but here actually 14 into 16 produces 224, which is involves a carry. You write the carry this way. Only two digits are reserved for this AB part. This is my AB part. So therefore, if this carry is there, the carry will be obviously added to 70. It actually basically becomes 70, and that multiply that n is 100 here. So basically it is 7,000. And then you are, because of this AB part is now 2224, you are having a carry on that. So it becomes 70. Okay. Or here, for example, here. Yeah, basically with that same formula, if you apply n plus a and so on, n minus a, n minus b. So if you like, it will basically it will be 8, 8, 6, 3, and the 10,000 are my base. This is my n. 0, 0, 0, 0. But my AB part is now my AB part is more than 5 digits. So what will be that? It will be 1, 4, 6, 1, 2. So this carry I write this way, and carry will be this last, it will be added. So it will be, obviously it will be 4. Okay. So this 3 becomes 4. So 33, okay. This 10 becomes 43. So is it clear? Multiplication of a base carry. No.
Yeah, Gautam ji, at this moment, we are at 750 plus. And any doubts they have, if they, up to this, if it is cleared, then we'll go for pradhana, etc. So, any doubts anyone has till whatever has been taught till now, you can raise your hand and ask the questions.
In my earlier course, I didn't consider this carry part. So this carry, carry nothing special actually. You write the carry in a small part and add with the previous part. That's right. That is the thing. That is the
Okay,
only thing you have to do.
Ramasharma Garu, you can ask your question.
Sir, good morning, sir. What is the meaning of word Nikhilam? Nikhilam.
Nikhilam Navatas, Charamang Dasata. Nikhilam means
What
all.
is that, sir?
Nikhilam Navatas, Charamang Dasata. It is all from 9. All from Nikhilam means everything. Nikhil means
Total.
Total. Everything. It didn't say that except is after that it is told. Nikhilam Navatas means that everything is from Navatah, means that from 9. Navatah means from 9. This is a Sanskrit actual word. And Charamang Dasata. Charamang means ultimate one, last one. And Dasata means from 10. So Nikhilam Navatas Charamang Dasata means that all from 9 and last from 10. Last one from 10.
Okay, sir.
Remove all numbers from 9. And then the last number from with
Here,
from
see,
10.
here, see, 9547. So here Nikhilam Navata, 9 minus 9, accepting 7, all from 9. So 9 minus 9 is 0, 9 minus 5 is 4, and 9 minus 4 is 5. But Charavang Dasata, this is Charavang. 10 minus 7 is 3. This is Nikhilam Navata.
Okay, anyone else? Radha Agrawal ji, please.
Yeah, good morning, sir. Sir, I just wanted to request if you could explain, if not today, then in the next class, the formulas the sutras and sub-sutras. As you have mentioned there, because we were not able to follow the PPT at that time. So would you
No, PPT is shared already. You can
I know. I know it is shared, but at the time you were explaining
it was off. No,
would it
actually,
be possible?
those things will come with the course during the course. If still something is remaining, I will be going. I can go back and those things. I can explain. Like Nikhilam Navdas Sarvaswati, you are always using. And tomorrow we'll be using Urdhati Jagabham, slant and you see meaning of that Urdhati Jagabham we will get tomorrow. Okay. Now, these are just in written online. I didn't explain. I just read them out. You can also read them from the
Slides.
slides. Okay. But explanation, actual practical demonstration of those things will come during the course of these lectures. Okay.
I hope you got it, Radha Raghavalji. What he says is, these are sutras. Okay. Only one or two sutras, as they are used, they are getting explained with mathematics and with examples.
Yeah, I
So,
got-
okay,
yeah.
right. Thank you. Anyone else who has any question?
Yeah, wasn't
Please raise your
the
hand. Otherwise I can't understand. Yeah, Sujit ji. Yeah. Go ahead. Go ahead.
okay. The rest of the things are understood only in the last one, no? The shortcut for multiplication of 1124 to 13, like you explained before. But in that, we are doing the conventional method of 3 into 4, 3 into 2, 3 into 1, 3 into 1, and then doing one offset, 1, 4.
Here you can do any method.
But is there a shortcut to do that? Because then we can come to the answer quickly, because 88769987 is direct from the number, and the minus of 1124 and 0013 is also immediate. But the only where it gets stuck up, then you do the cross minusing, that also you get 8863 immediate. From 8876 you take out 13, or from 9887 you take 1124, you get this 8863. But to get to 14612, it will actually do the
You
laborious.
multiply, you can use any method. You see, learning basic mathematics doesn't mean that using conventional mathematics will be banned or you forget conventional mathematics.
So I wanted to
Conventional
ask,
mathematics is also one of the procedures.
is there a shorter
That
method?
actually, maybe in India, so many people used to use so many procedures, arithmetic procedures, but only few are accepted as common practice. Others were forgotten. That is the basic mathematics are doing the others one or we are getting now. But it doesn't mean that or conventional mathematics, they do the 13 into 4, 52, and then 13 plus 13 into 26 plus 5 is 31. That way you do.
Yeah, if you know the table of 13, it becomes easy. But otherwise, you have to do is there a shortcut to do this, or like the other shortcuts you gave?
Shortcut means you have to do another, you have to open up another procedures. You do by Urdhva Trijagabham, you can one is practice with Urdhva Trijagabham, one can do it very easily. 0013, 0013. This one, like this one, as I told earlier. It can be, if it is bigger, obviously use this Urdhva Trijagabham or any procedure. You can do conventional mathematics also. No harm is small numbers are there. You do Urdhva Trijagabham, no problem. But in case it is say again you want to avoid 9 and 8 and so on, you have to convert them into vinculum and use them. That is also there. Okay.
Thank you.
Any of the procedure you are learning alternative procedure here, so you can use any of the procedures, either conventional one or newly learned one. Okay. Now, only one thing I will end up with only one thing on there, that if what happens if the carry then becomes negative. So here also one example is given here.
Yeah, Gautam ji, we are at 8 o'clock.
Yeah.
So we have to stop here.
Sure,
and then we'll take up whatever is balanced tomorrow on the next class.
Okay.
Sorry for the
No
disturbance.
problem.
Yeah. Basically, I want to say one point regarding this last example of what Dr. Sujita said is that this, as Gautam Mukherjee has said, the Vedic mathematics is not only exclusive. You have to have a combination of doing things. So, for example, this last example of 10123, I am not able to read the numbers because I'm on the mobile. Basically, you have brought down the entire multiplication of complicated numbers into a very simple one, and finally ending up with multiplying a small digit wherein it is a multiplication of 13, which is a simpler thing. So here you can do the hybrid of Vedic mathematics and conventional mathematics.
Yeah.
So you bring it down to a simpler one and do the conventional one and get your solution. That is what is the importance. Okay. Now, thank you, Goutham Mukherjee ji. With your permission, we'll go for Pradhana.
Yeah.
Thank you very much. Ram Sharma garu, can you do the Pradhana, please?
Yes. स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रेण
What happened? अपुत्रा पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अदना सदना सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान् मान् प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ओम शांति 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 ओम पूर्णमद पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ओम शांति 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 सर्वे जना सुखिनो भवन्तु स्वस्ति. Thank you, Ram Sharma garu. Now, Vasundhara garu, can you do the national anthem, please?
जनगण अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे गाहे तव शुभाशिष मांगे गाये तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हे.
Thank you, Vasundhara garu. Thank you for the national anthem. Now, I end this class. I'll stop the recording first.